Hello everyone, let's talk about congestive heart failure today. So, congestive heart failure generally is divided into two types. There's left side and right side. And so, let's talk about what that means in reality. The heart is a funny conglomeration of tubes and vessels and things sticking out of it and muscles wrapped in muscles. And that can get really confusing when you try to draw it as it really is. And so it's much better to think about it separately, that there is a side of the heart that is the right side, which is a low pressure system that pumps from the body to the lungs, where the lungs pick up oxygen and offload CO2. So O2 in, CO2 out. Right? And then the left side of the body is a high pressure system. We'll get into that in a second. And it takes blood from the lungs and pumps it to the body. And that is oxygenated blood that now gets to go out to the body and get used to do things like make energy, digest your food, provide oxygen for your muscles, things like that. So let's talk about how that works. So blood vessels come in from your body. So your head might be up here and your feet are down here, and they come into the right side of your heart into a chamber called the right atria, and there's a valve, a one-way valve, and then goes into a pump, and that pump pumps out. And there's a pulmonic valve, and this is a thin-muscled right ventricle. So atria, ventricle. Okay, so that pumps to the lungs, and I'm going to do a little fifth element magic here of a wind. This is the lungs, two kidney beans looking type things, but remember these are spongy, air-filled sacs that are your lungs. And then coming back from the lungs, we're going to have a blood vessel come back, go to another atria with a valve. It's the mitral valve. That was the tricuspid valve. I hope I didn't say anything wrong there. And this is the mitral valve, so that's the left atrium, into a pump. Now this is a pump. This is a thick-walled, big pump, the left ventricle. And then there's the aortic valve. So let's do that again. Right atrium, tricuspid valve, right ventricle, aortic valve, to the lungs, back now to the left atrium with the mitral valve, the left ventricle, and the aortic valve, and that goes out to the body. And that's the aorta. So that's the circuit. So what happens when things go wrong? Well, a valve might be leaking here, so that when this left ventricle goes to pump forward and squishes out, if there's a hole here, when it goes to squish forward out the aorta, some leaks back here. Now that increases the pressure in the left atrium, and then the left atrium says, okay, I'd hold a little bit more, I'll stretch. And then the hole gets bigger. Oh, I'll get a little bigger and I'll hold some more. To a certain point where the pressure starts to go back, and maybe only a little bit is going forward, and the body says, hey, I need more. Sad face. Hold on to get me some more blood flow. And a lot of it is going back. So these get real big, which is what you see on echo and things like that. And then it can start to fill the lungs. And that is congestion, just like you might have congestion of your mucous membranes. So in cats, the other thing that can happen when the left side has heart failure, which is usually pulmonary edema, is they can also get fluid around the lungs. And that is called pleural effusion. But cats like to do weird things. Dogs generally have to have right-sided heart failure, usually to have pleural effusion. So dogs and cats can be a little different. So right-sided heart failure, what would happen if that? How would that happen on this side? Let's say there was a leak in the tricuspid valve and things were going that way. Well, that would go to the body, right? Well, the normal place that starts to back up to if there's a problem is in the abdomen, and you will see ascites. So we talk about things sometimes as in cavities. So if there's bicavitary heart failure, that might mean that there's pleural effusion and ascites in a dog. If it's tricavitary, it might be also in the sac around the heart, which cats like to do, pericardial effusion. Pulmonary edema, though, is what it's called when it goes in the lungs. And so that is left-sided heart failure. Pulmonary edema is always left. Ascites, if it's heart failure based, is right-sided heart failure. And pleural effusion in the cat can be either, but in a dog is usually right-sided heart failure. So I hope that makes sense. Basically, whenever your heart cannot pump forward enough and some goes backward, the pressure builds up in either side. And that's why they call it left-sided or right-sided. But let's talk about strategies to get rid of heart failure and why we have some different strategies. So if we think about this as one air sac, one alveolus, so one alveoli, and there's a blood vessel running by, that makes it a little easier. It's very close. Think about it like that. I'm using more colors today. So let's say the pressure builds up here. So the pressure is building up. This is the blood vessel. This is the same thing. And it's getting bigger and distended, and then some of that leaks into the alveolus. And so now that alveoli is full of fluid. That's pulmonary edema. Now, how can I get rid of that? Well, I could cough, right? And that's why we see a lot of our heart failure patients cough. There's a lot of lymphatic drainage here, and that would just go and drain out. But if there's a lot of fluid, that gets overwhelmed. And if this is high pressure and the blood flow is going this way, it can't flow out. So one of the strategies is to decrease this pressure and make it so that more is heading forward. Well, how can we do that without replacing the valve? We can use a diuretic. So a diuretic decreases the load to push against, which then decreases the work of the heart and increase the amount going in the correct direction, the fraction going in the correct direction, and then decreases the pressure there. So the pressure here, that's called afterload. That's the load that the heart has to push against. So a diuretic will decrease that. There are also, after diuretics, you can certainly do things like vasodilators. So a vasodilator will increase the blood vessel capacitance out here. So in my feet and in my gut and in my muscles, I can hold more blood out in the body. So less is held in the heart. The heart doesn't have to work so hard. More is coming forward. Less is getting pushed into the alveolus. And so some of those are like hydralazine and the nitrates like nitroprusside and nitroglycerin. And that's why we use those medications too. So you can also reduce what's called the preloads, the amount that gets pushed in. So diuretics, by dehydrating you, also decrease preload and the amount that gets pushed into your heart at the beginning. And so anything that dehydrates you would decrease preload. And, basically causing a little bit of hypovolemia. So what that does is decreases pressure so that you can cough and your lymphatics can drain and the rest can be taken away. Diuretics are the fastest way to do that. The other things don't work quite as quickly and have some other side effects like low blood pressure. Well, this was an awful messy diagram, but I hope it made some sense to you, at least as an introduction of the things that we do for congestive heart failure.